The last algebra video of the year. All right, we are going to now shift from looking at quadratic equations to quadratic functions. And the only difference now is instead of solving when a quadratic equation equals 0, we are going to be graphing this quadratic function in the xy plane. So a function is anything where we just say there's one output for every one input. Remember that. So a quadratic function is one that looks like this. Y equals ax squared plus bx plus c. For every value of x that I plug in into this side of the function, I will get a corresponding y value. We'll look at the easiest quadratic function to start with, y equals x squared. When you don't know how to graph a function, you can always think of making a chart. So we usually start our chart with 0, but I'm going to start with -2. And I did that for a reason. You'll see why when we get to 0. So we plug in our x values right here and we square it. Let's start with 0. 0 squared is 0. 1 squared is 1. 2 squared is 4. Pretty easy. Plug in these negatives. Remember, it would be -1 in parentheses squared. It would be -2 in parentheses squared. And we would get 1 and we would get 4. So we get this nice equation. Notice where I put my x-axis and my y-axis. This nice picture of a function. 0, 0, 1, 1, 2, 4, 3, 9. We would go 4, 16, 5, 25. Notice that they're not going up by a linear function because it's not a linear function. Over here we get the same thing. -1, 1, -2, 4, -3, 9. And we get this shape that kind of has it looks like a U, but it's not really a U because it gets wider and wider. But a lot of math teachers will say U-shaped. It is called a parabola, or parabola if you want to know how to spell it. But most people pronounce it parabola. So, a couple important things about a quadratic function. All quadratic functions have vertical symmetry. Notice in this one, the y-axis is acting like a mirror for the function. We call this the axis of symmetry. It doesn't have to be the y-axis, but often it is. In this case it is, but it doesn't have to be. Notice that every point on the parabola has a corresponding point, except one. This one right here, which I will color red because it's special. This one is called the vertex. Notice some other things about this parabola. This parabola is always opening up. Parabolas will either open up like this one, or they'll open down like this one. And it all is, we can predict it without even graphing by looking at this value. If the number in front of x squared is positive, it opens up. A equals positive. If the number in front of x squared is negative, it opens down. Good? So just some general things about quadratics. The graph of any quadratic function will have this U shape. Now, it may be skinnier or wider depending on certain values. So you can have a parabola that's real skinny like this one. Or you can have one that's real wide like this one. And you can have parabolas that start at 0, 0, or you can have parabolas that don't, that start out here. And you can have parabolas that hit the x-axis in 2 places. And we'll talk about all those different kinds of parabolas. So, Again, key terms, just to review. We've got the shape is called a parabola, a U shape, parabola, parabola if you spell it. The vertical line that cuts the parabola in half is called the axis of symmetry. The only point on the parabola and on the axis of symmetry is called the vertex. A parabola will open up or down, never both. Parabola will open up or down, never both. And then we will say a parabola can be narrow or vertically stretched. Narrow or vertically stretched, if you want to sound more like a mathematician. Vertically stretched. Or it can be wide or vertically shrunk. And that will all depend. We'll talk about what makes that happen. Narrow and wide are relative terms, so we're always talking about relative to the parabola we just graphed when a equaled 1. This parabola, y equals x squared. The most basic one. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 10, 100. And that parabola looks something like this. So this one we will say has no stretch. It's not narrow, it's not wide, it's what we'll compare to. Good? All of these terms are important to know, and all of them can be found using the variables a, b, and c. All right, so how are we going to take a quadratic function and figure out how to graph it? Well, much like the quadratic formula, we're going to have to memorize some things. But the good news is they're kind of related. And by kind of, I mean they're definitely related. So, y equals ax squared plus bx plus c. The first thing that we want to look at is a. And a will tell us a lot of information about the graph. First, we will look at what a equals. If a is positive, then the parabola opens up. If a is negative, then the parabola opens down. If a is bigger than 1, and we're going to use absolute value, if the absolute value of a is bigger than 1, then it looks vertically stretched or narrow. If the absolute value of a is between 0 and 1, then it's going to look vertically shrunk. The other nice thing is, let's skip ahead and look at C. C will tell you the y-intercept. Whatever C is, it is the y-intercept. And remember, the y-intercept is the value of y when x equals 0. Look at our equation. Y equals ax squared plus bx plus c. If I plug in 0 for x, I get a 0 here. 0 times b is 0. 0 squared is 0 times a is 0. All that goes away, and I'm left with y equals c. So c will always be the y-intercept. And then lastly, b doesn't tell us anything directly, but it helps us find the vertex. The x-coordinate of the vertex is always going to be the opposite of b divided by 2a. And if that looks familiar, it is in the quadratic formula. So the x-coordinate of the vertex is always negative b over 2a. How do you find the y-coordinate of the vertex? Well, whatever this is, you plug it in for x and you solve for y. So let's take a look at how we use all of this information and use it to graph a quadratic function. I took a photo of that last screen, and I have it shrunk down in the bottom corner, so if you didn't write it down, it's down there. How do we use that information to graph a quadratic function? So I'm going to give you something like this. Y equals x squared minus 4x minus 1. First thing you're going to do is you're going to identify, just like you did with the quadratic formula, your variables. A is equal to 1. B is equal to -4. C is equal to -1. Now you're going to go through all of these things down here with this information and kind of figure out what the graph looks like. So first, A is 1. What that means is that this parabola opens up and there's no stretch. Remember, we have to compare it to something, and so stretch. And so we just say that when A equals 1, that's a regular looking parabola. Next thing we're going to do is we're going to write the y-intercept down. The y-intercept is C, so I know the y-intercept is -1. And now I'm going to do a little bit of math. I'm going to say the x-coordinate of the vertex is -b over 2a, so -b over 2a. And I'm going to plug in all the information I know. That's -b over 2 times a. So b is -4, so I plug in a -4. A is 1. I simplify and I get +4 over 2. +4 over 2 is 2. And what that means is I can now plug in x equals 2. That's the x-coordinate of the vertex. If I plug this in here and solve for y, I get y equals 2 squared minus 4 times 2 minus 1. I plug in 2. 2 squared is 4. 4 times 2 is 8, so this is 4 minus 8 minus 1. 4 minus 8 is -4, -4 minus 1 is -5. So the vertex is the point, 2, -5. I put all this information together. I graph the vertex first, 2, -5. So I go over to x equals 2, I go down to y equals -5, and I graph a dot right there. The next thing I'm going to do is I'm going to graph the y-intercept, which is -1, which is right here. Now, to finish graphing this parabola, I know it opens up, I know it hits this point, and I know this is the vertex. I know that the axis of symmetry is a vertical line that contains the vertex. So what I know is that this point here, which is 2 spaces away from that vertical line, has a mirror image 2 spaces away right here. And I can graph that point. Now, I can use this vertex in a variety of ways. I can find that a value, which is 1, and I can go over 1 and square that and get 1, and multiply by this one here, and 1 times 1 is 1, so that point would be on there. I could go back 1, and 1 squared is 1, times 1 is 1, and that point's there. I could go over 2. 2 squared is 4. 4 times 1 is 4, and I go up 1, 2, 3, 4. And look how I'm right at that point that I already knew was on there. I could go back to -2 squared is 4. 4 times 1 is 4, and I go up 4, and I'm right here. Point I already knew. So now I can graph this quadratic function by doing my best to draw this U shape that goes up. And that's it. Let's try another example. Let's try another one, a little more complicated this time. Same idea, we just follow the rules. So let's say y equals -3x squared plus 6x plus 1. All right, we start with the a value. Well, we start with all the variables. A is equal to -3, b is equal to 6, c is equal to 1. A equals 3. That tells me that my parabola opens down and it's vertically stretched. I say vertically stretched because the absolute value of A is bigger than 1. That means it will look more narrow than the last few quadratics we've graphed. I know it opens down because I have a negative A value. The next thing I'm going to write down is the y-intercept. The y-intercept, pretty easy to find. It's just the value of c, which is 1. Remember, this should not be something we have to memorize, but something we understand. Plug in 0 for x and you would get 0 plus 0 plus 1, so we know the y-intercept's 1. Lastly, we're going to find the x and y coordinates of the vertex. The x coordinate of the vertex is this formula. The opposite of b over 2 times a. So that's what x is equal to. So the opposite of b over 2 times a. So what's b? B is 6. What's a? Negative 3. When I simplify this, I get negative 6 over negative 6, which is equal to positive 1. So that means the vertex has an x-coordinate of positive 1, and I need to find the y-coordinate. The way I find the y-coordinate is I just plug in 1 for x up here. So I get y equals negative 3 times 1 squared plus 6 times 1 plus 1. So that would be 1 squared, which is 1, times negative 3, 1 times 6, which is 6, plus 1. Negative 3 plus 6 is 3. 3 plus 1 is 4. And now I know the vertex is at 1, 4. So I graph my quadratic. I draw my y-axis. I draw my x-axis. I go to the vertex, 1, 4. So 1, 1, 2, 3, 4. And I draw my vertex right there. Label this x and label this y. I draw my y-intercept of positive 1. That's right here. I now use some things I know about quadratics, that they all have an axis of symmetry, which is a vertical line that goes through the vertex. This point here, which is 1 away from that vertical line, has a corresponding point 1 away right here. Another way to find these points is to use the a value of negative 3. What would be happening mathematically if I was to walk 1 step away from the vertex? I would take 1 and square it, and 1 squared is 1, and I would take that 1 and I'd multiply by negative 3. 1 times negative 3 is negative 3, so that must mean I go over 1 and down 3. Do you see how that matches up? I'd do the same thing if I went this way 1. If I go this direction 1, I would be going negative 1 in the x direction. Negative 1 squared is 1. 1 times 3, negative 3 is negative 3. And notice I'm down 3. If you wanted to get more points, step over 2. Take that 2 and square it. What's 2 squared? You get 4. But now you don't go over 2 and up 4. You go over 2 and down 4 times 3. You're going down because of the negative. 4 times negative 3 is 12. So you would go over 2 and you would go down 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It'd be way down here. And do you see how you're getting that real narrow shape? Good? Now, you can always check this algebraically. Look at what the x-coordinate here is. It's 3. If I plug in 3 in for x, I would get 3 squared is 9. 9 times negative 3 is negative 27. Plus 6 times 3, that's 18. So plus 18. And then plus 1. Negative 27 plus 18 is negative 9. Negative 9 plus 1 is negative 8. So what that means is the point 3 comma negative 8 is on the graph. What I told you is you should go down 12 from this y value of 4. What's 4 minus 12? Negative 8. So that is how we can generate points to graph a quadratic function. Notice how that graph opens down and is kind of vertically stretched or more narrow. Good? We'll do one more example. Here we go, our last example of our last algebra video. So this time it's going to look a little ugly to start, but I'll show you why it's kind of a nice one as well. Y equals 1/3 x squared minus 5. Start the same way we start every single quadratic function. Write down our values. A equals 1/3. B equals, be careful, 0. There is no x term, so B is 0. And C must then equal -5. Using those numbers, we just plug in like we have the whole time. If A is 1/3, then this parabola opens up and is vertically shrunk. It's going to look wide compared to y equals x squared. The y-intercept is equal to -5. And the x-coordinate of the vertex is the opposite of b over 2a. The opposite of b is -0 over 2 times a is 2 times 1/3, which is 2/3. 0 divided by anything, well, first -0 is 0, and then 0 divided by anything is 0. And if the x-coordinate of the vertex is 0, then we're talking about the y-intercept is where the vertex is. I plug in 0 here and I get -5. This is the vertex. So that's going to be a little hard to deal with because now what we have is we have our y-axis. We have our vertex at 0, -5. We can't use symmetry because symmetry is the vertical line through the vertex. So we don't have a point to reflect over our axis of symmetry. But I know my parabola does something like this. Why do I know that? Well, A is positive, so I know it opens up. Why am I way out here? Well, I know it's vertically shrunk because this is a number that when I take the absolute value of it, I'm between 0 and 1. You probably won't like this, but I think the best thing to do is to plug in an x value and just find the y-coordinate for that x value. But we get to use symmetry. If I plug in 1, it's the same as plugging in -1. If I plug in 2, it's the same as plugging in -2 because all quadratics have this symmetry. And the symmetry right now is the y-axis. I'm going to tell you though, look here, and because we have a fraction here, I'm going to choose my x value based on that denominator, and I'm going to plug in x equals 3. So I'm going to solve for y when x is equal to 3. 1/3 times 3 squared minus 5. 1/3 of 3 squared, that's 1/3 of 9, or you can think of it as this 1/3 cancels with one of those, and I get 3 minus 5, which is -2. And I can go over 3 and down 2. Oh, that's the wrong value. Over 3 and down 2. Over 3, down 2. Sorry, that's right here. Let's use a different point or different color. That point is on the parabola. Over back 3 and down 2 is also on the parabola. We know that because of symmetry. And now I'm done. I can just connect those 3 dots with my nice wide parabola. Good? You don't have to choose 3, but 3 is a good point to choose. Another one, x equals 6. Another one, x equals 9. All of those are divisible by 3 when you square them, so that's why I would choose those. If you chose 1, you would get a really ugly number in here. You can deal with that, but it just doesn't look as nice. All right, we'll practice this a lot on Thursday. Have a wonderful day. Peace.